Let's understand what is reverse bias and what happens in reverse bias condition. First thing, reverse bias is that condition in a p-n junction where p-type is connected to negative terminal and n-type is connected to positive terminal. Okay, this condition is what we call as reverse biased condition. Fair enough? Now in reverse bias condition, what exactly happens? Like when you connect this is the circuit. Okay, what do we do? So as you guys are seeing the circuit, first thing what happens is that the holes in the p-type and the electrons in the n-type, both of them are pulled apart from each other. In the sense, the holes are going to get, you can say that the holes are going to get filled up because of the excess electrons in the negative terminal of the battery. Basically, they come and they fill up the holes. That means the holes are pulled away from the depletion region. Same thing happens even for electrons in the n-type. Because n-type, it is electron rich. Majority charge carriers are electrons. It's like the positive terminal of the battery is pulling the electrons from the n-type. In the sense, the depletion layer what we have, whatever the width of the depletion layer we had, it's going to increase. When that increases, the potential barrier will also increase. Correct? That means whatever the charges it was, crossing over, that is going to stop. Fair enough. It's like, imagine you have, like a water, like a stream of water. Okay, if that stream, because of the rain, if it becomes a river, then we won't be able to cross. That's exactly what happens in a reverse bias condition. First, you have a small depletion layer, then the depletion layer will increase. It becomes more thicker and thicker. So, no charges can pass through it. That means majority charge carriers which were crossing over, now it is stopped. But what happens here is, no matter how wide it is, certain charges, they jump. Why? Because of kinetic energy or the electrical energy. There are lots of other things. Because see, there are very few number of electrons in p-type and very few number of holes in n-type, correct? They cross over the depletion region. Once they cross over the depletion region, they constitute very, very, very small current. This current is because of the minority charge carriers. We call this as reverse current or sometimes leakage current. Fair enough? Once you have this reverse current passing through the, the depletion layer or the junction in a reverse bias condition, that current what we get is very, very important. The reason is the resistance of this particular, condition, the reverse bias condition, will be very, very high. Okay, it will be extremely high. It will be in few terms of kilo and mega ohm. It's very, very high. Okay, again here also it's a dynamic resistance. Okay, and when we talk about dynamic resistance, again R is equal to delta V divided by delta. It's the same thing. Now this is how it works. Now let's understand the characteristics of reverse bias condition. See, in reverse bias, look at this particular circuit. See how the diode is connected to the terminal of the battery. You have voltmeter and you have microammeter. Microammeter because minority current, right? The minority charge carrying current will be very, very, very small. It will be in the order of few microampere. That's why. What happens? Let's understand. You have the potential, you have the V source. Start increasing the value. You increase, the depletion layer will widen a little bit. More you increase, more it's going to increase. Keep on increasing. But after a point of time, the width of the depletion layer will be so much that if you give more potential to it, the depletion layer is going to break down. This is what we call as breakdown voltage. So in breakdown voltage or during that breakdown voltage condition, large amount of current is going to pass through. Because that layer what was blocking, not blocking, you can say the layer what was stopping the majority charge carrying movement, that breakdown, that layer no longer exists. Now this condition is what we call as the breakdown condition. So under breakdown condition, large amount of current is going to pass through the conductor, or you can say through the semiconductor, that one. Look at this particular graph. See the current, what you see, that is the reverse current. Now beyond that one particular value, can you see the increase in the current? It's almost parallel to y-axis, correct? And that means we'll have infinite current. I mean, practically that's not the case. It's just an ideal case in which it's going to happen. That means we are going to have a lot of current after the breakdown voltage. Clear? So once we have this, we can calculate what is the resistance. Don't you think within that small voltage and current region, the resistance will be very high? After that, the resistance will become very, very, very small. Clear? So under reverse bias, what are the points we need to remember? Like quick summary. First, what is reverse bias? You should know how it is connected. P-type to negative, N-type to positive. This is the first very important thing. Second thing, what happens to the depletion layer? The depletion layer increases and the potential barrier also is going to increase. Third one, what happens to the resistance? Resistance in reverse bias is very high. Correct? The next one, in characteristics, you need to know the graph. Okay, so in the graph, there is that one voltage beyond which the current is almost infinite. Okay, almost like extremely high. What is that voltage? It's the breakdown voltage. And of course, you need to know the graph. This is what we have in a reverse biased condition. So both you understood forward bias and reverse bias. Under forward bias and reverse bias, understand the graph, understand what is the resistance, and there are two voltages, correct? That also you need to know. Now that you have understood the working of PN junction, let's try to understand what are the uses of PN junction from the next video onwards.